Okay, I think I fixed it. Thankfully. Um, thankfully. Yeah, even though it says gaming category, but that's bullshit. Stream settings. Customization. Oh, fuck's sake. I need to go through and do all this now. Oh, no, it's fine. Science and tech. Aye, sure. Thumbnail's fine. I think we're good to go.
Sorry.
Yep, we're good to go. Okay. So I was basically saying in the last thing before it wasn't showing me any analyticals that basically in VS Code, prefer on Linux because I don't know how to get it working on Windows. Look up Teros HDL, and then if you scroll down to the yep, open Sasami, open Sashimi, and then get started. Installation checklist, prerequisites. Let's go through this crap. VS Code, Python 3, then these Python packages which we will need to install, and I'll probably need to make a Python environment because Ubuntu makes you do that now. Need to install Python. Install Python. Pip, not pop. Pip. Yes. Python should already be installed on Ubuntu. That's annoying. Maybe they've started separating it now between what do you call it? The system and the user one, because that's ultimately why they start making you use a VM, because they don't want you pissing about with the packages on the system. So let's try this again. Bish bash bosh. Womp womp. Okay, so Python 3 VM. I'm gonna do this here and call it Python env. Here is in the home directory. And then, oh fuck me. Gonna install this instead. Or not instead as well. Yes, 2 megabytes, 3 megabytes, it's fine. Yeah. And then activate go here, Python env, bin activate here. Right, we're in our env now, so clean that shite. Close this shite. And install this shite. And then we can see if, well, install the rest of the shite. I need to install make. Do I need to install make, or is that, oops. Yeah, let's install make as well. Sudo apt install make. Already installed, cool. EDA tools, I don't think you need them. Do you need them to use Verilog? You need to install Vivado. I don't care about the linter. How do you install Teros HDL? You basically go to that thing there and install it there. Verify. Okay, let's try and see. Click that there, sir, and then open that, sir, and then hope for the best, sir. Oh, this may take a while. It's trying to run. It might shit itself, but it might work. It looks like it's maybe gonna work. Just with the Python stuff. It's just easier to do this on Linux. Forget the, well, I'll say that when it works. But forget Windows subsystem for Linux. Just get a good old Oracle VM, Oracle VirtualBox VM up and running with Ubuntu or Debian. Although Debian's a bit awkward sometimes with some things I find. And the problem with this is just fucking stupid slow. I've given this plenty of cores, plenty of RAM, plenty of hard drive space. There is no excuse for it to have just fucking shit itself and crashed. Oh, wrong webcam. Fuck's sake. You're in the army now. This is the one thing. One pin. Not one pin in the ass. There's multiple pains in the ass about YouTube. But one of them is you can't even listen to the tunes. I need to reactivate this as well. Fuck's sake. Source, Python, no. Bin, activate, and then documents, and then that yoke, and then code, and then prayers. Hoping this works. If you are doing this on a normal machine, it shouldn't shit itself like this. It should just work. Let's go through all this crap again. This may take a while. Please don't crash. You bastard. It works really well whenever it does work. It's just the VM is a bit gack. Oh, yeah, there we go. It works. Cool beans. So this is basically how you can oh, the output is the drain. You can use Teros HDL to like auto generate these sorts of schematics. So if we look at the NAND gate, it should just update, yeah. Only it does it with PMOSs and stuff. So if we go and do the 2-to-1 CMOS mux, that looks a bit better. So it's taking our CMOS, which is just one CMOS gate, a CMOS NOT gate, and another CMOS transistor. So two CMOS transistors and a NOT gate, and the NOT enables or disables like which one. So like alternate. So if that one's 0, then I'll pick this one. If that one's 1, then I'll pick this one to like be the output. Cool, that's how you do that one. You basically just go and install a couple of Python packages and it works. And Teros HDL. But as I say, don't do it with the Windows WSL because it'll go and try and look for them on your Windows machine. And they won't be there. So that's fine. Right, onward. What am I gonna do now? Oh, gonna sleep. Yeah, I'm going to go through the remainder of this. Just gonna keep going through this book. So we went through the last bit was transistor level stuff, which is basically your MOS gates, which is what these are, the PMOS, CMOS, these things. But it's just an NMOS, and then we've just called it the negative MOS and the PMOS. Well, no, we haven't. The NMOS is N1, the PMOS P2. I don't know what I'm saying. So the dual stream is a bit pish. I don't know how you fix that. Oh well. Let's go and read through this. So we give two circuits of the multiplexer. So this is one multiplexer with these tri-state gates. And then this is one with and, or, and not gates. And then, did we do this? No, this is 3S. So 3S, I believe, is the tri-state. Yeah, it is. Okay, so this is the code for the tri-state gates. So I'm just gonna make an R folder. I'll just copy that one, sir, and rename it hey to 3S. And I'll 3S a shout out that one too, sir. And that one again, sir. So let me change the module name of this as well. 3S. Hello, Cammy. Right. That's the 3S, so A, 0, A, 1, S, and Y. That's alright. So all those are fine. And then we need our BufFIFO. We haven't made that tri-state buffer yet, have we? I don't think we have, unless it's all the way back here where I didn't make it. I hope not, because that'll be a bit shite. Fuck me, it might be. Shouldn't be. Bleh. Let me see. BufFIFO. Okay, it looks fine. BufFIFO. BO. BufFIFO 1. B1. And then we're gonna do this. I'll fucking YA0S. And then same thing down here. No, I'll copy that. A1S. Get rid of that. Get rid of that. So I'm just gonna copy this. Ah, you bastard. So I forgot. I don't have the thing installed, so copying from here to you can't fucking see what I'm pointing at. From here to here isn't enabled because I didn't enable it. Alright, inst and then CTL is just control. So if control is equal to 0, then out is equal to in if CTL is equal to 1, then out is equal to high impedance, which basically means it won't output anything. And then end module down there, and then we don't have a test bed. The Verilog HDL code implementing the multiplexer for tri-state gates is listed below. BufFIFO1 and BufFIFO2 are gates supported. Okay. And then I think we can do this. I think we can do the same test bench, to be quite honest with yous. I think I'll just run the same code, which is fine. 3s. We'll try and see. I need to open the terminal to run the thing. And just chmod the shit out of it. Run test. We're not in that folder, that's why. So cd chapter 2. And then mux fux 3s and then chmod u plus x run that shit, smack that on the floor, and it should be the same output as over here, although it's a bit why is that like that? Okay, it's fine now. I hit something, so it like unaligned everything. So times 0 to 8, that's fine. So that should all be zeros until 3 and all ones. All zeros, all ones, yep. And 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and then 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1. Okay, that's all working fine. So we've basically done the same. These two are the same things, just this one's done with our own gates. So transistor, transistor, not gate, and then oh yeah, whoa, is it? Yeah, is this just yeah, it is. So yeah, it's basically the same thing, and then 2.10 shows the gate level. So instead of doing it with these two buffer thingy yokes, my bobs, we use a NOT gate, two AND gates, and an OR gate, which is my personal favorite because that's the one I recognize. So MUX gate. So multiplexers are really good because they can help you switch between things. So multiplexer. So if I have an input, it's A and input B, and I want to switch between the two, you can use a multiplexer, and like a 2-to-1 multiplexer will do that. Multiplexers are also good for driving 7-segment displays. If I can find one. One of these things. But the multiplexer is good for switching and picking things. So, right, we need to relabel that to gate. Relabel that to gate. Yeah, gate that shit. I don't think we need we don't need these in here. They can fuck off. Gate. So the gates are basically everything's the same here, and then we have a wire. We have 3 wires this time instead of 1. So A0 SN and A1 SN, if I remember right. Did I remember right? A0 SN A1 IS. I nearly remembered right. Okay. Internal wires. Whoop. Does anyone know about Verilog here? I do. That's a lie. I don't. That's why I'm going through the book. So we need to not. Oh, Derek, I need to show you the. I don't know if you've seen this, but I got the thing working. So you can view like auto generate the schematic. As if it doesn't shit itself and break on me again. Is it gonna work? 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 It will work. It's just being pish. Oh, whoa. Why is that? Did I? Oh, I needed them in there. I'm an idiot. There we go. That's why it wouldn't work because I couldn't find them gates. So it'll just auto generate this for you now. It can also do a not auto generate the NAT gate. So this is just our PMOS and NMOS. That's handy. I'll do this one. This gate one, I'll generate it when it's done. So that's our wires. What else? We need a NOT gate. I0. 2 ANDs. And an OR. I3. I2. I1. Why the fuck is that? Okay, the NOT is SN to S. The AND is A0 SN, A0 SN, and then A1 underscore S, A1 S, and then this OR isn't working right for some reason. Why not? I don't know what's wrong with that. Doesn't like the OR. Y. Y is the output. And then we have A0 SN, A1 SN. Yeah, I don't know why that OR isn't working properly, but hey ho, hey ho. It's off to work we go. No, it doesn't like that. I don't know why it doesn't like that. What the fuck is wrong with the OR? Definitely OR. 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 What the Oh, I'm not in the mood for this today. There's like, oh, what? Eh? No, that's not right. Nor? Nor's fine. How do I spell? Right, Google, help me out. Or not recognized. Verilog. Something weird going on here, boys and girls. Or git. Or. I don't need to implement it. It should be built in. Shouldn't it? Derek, help me out. Am I being stupid? What's going on? Not the shit out of it, but I don't want not the shit out of it. I want this to work. So if I do nor, see updates. Like it's not right, but it updates it. Or is ready to use keyword. I think it is, yeah. It's just been weird. I see. I'm gonna close this and open it again because it's been fucking weird. What the devil? There's fuckery afoot. I don't know if that was audible, but my stomach just made a noise. Eh? Or is definitely and or XOR NAND nor ner. Womp 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 womp. Okay, this is actually doing my fucking head in. Why is this not a thing? Verilog. Check the input and output. No, but it shouldn't matter. Like, I expected it wouldn't work if that was if what you're saying. Like, it wouldn't work. That's not the issue. The issue is, like, when I type, you might hit an error. No, but look. As soon as I type and, it changes to green, so it knows it's a keyword. Or should just be green. Wire's blue. Logic will be blue as well. Reg will be blue. Oh. AN wire. Let's see, it knows all. Is this your first time using OR? Yes, because I don't really. This is like gate level stuff. I don't really do this, so I don't. I've never really needed to. Let me go back and see what this code. Input S, and just in case there's something fucking stupid going on. Well, there's at it. New. Oh, okay. Apparently that was it. You're right. Well done. I was being an idiot. So A1 S, and I had A1 SN. Why has it not changed fucking there? That would throw anyone off. Okay, so same test bed. I just need to change this to gate. Gate. I'm just gonna keep this all the same, and then the test should run the same as well. Chmod u plus x run. So I'm gonna look at the output 01010011. Yeah, that's alright. Cool beans, right? Next we're on the data flow level. So basically everything again, but one-liners. Yeah. I'm gonna copy and paste the shit out of that. Data flow 1. I think this is getting a bit tedious now, doing the same thing in the different levels. To be honest. Data flow 1. And the test bench will be the same. It'll be data flow 1. And then the data flow, I'm going to get rid of all of these. And then the output is basically assign y is equal to not s. Which, if we look, I'm going to put this beside, no, not this one. 3s. No, it's test bench. Alright, bear with me. I'm going to put these beside each other so you can see, and then I can sort of talk through it. Ah, fuck, that's a test bench. Get that one over. So, SN is an input. Is it an input? No. Is it an input? S is an input, SN's the output. So we're gonna not S, which is what this is doing. And then, and that fucking thing there. So we and SN with A1. And then we get AOSN. AOSN is basically equal to those two. So you don't need to write it, you just need to go A0. Not there because that's wrong, A0. And you do OR, and then S, and A1. And that's basically the whole thing done on one line. So there's literally no difference. And then this bottom one is called, do they tell you what it's called? They don't. It's a ternary operator. It's basically a really fancy way of going if else. That's it. It's just the fanciest if else ever. What are the types of programming style in Verilog? Data flow gate. So there was the first one with CMOSes was transistor, gate, data flow, and behavioral. So transistor switch level, which I'd never heard of before looking at this book. Logic gate level, data flow style, behavioral style. So the behavioral style is actually how I would tend to use them, which again, that might not be the right thing to do. So different from transistor and gate levels, the Verilog HDL code in Dataflow style does not use any particular component, transistor, or gate. It uses the keyword assign and logic expression to assign a value to a net or an output. A net or an output can be assigned only once in the code. And below is the Dataflow style. Yeah, the Dataflow style is just a nice quick way of doing it. I'm not even gonna do this one because I feel like we're just doing the same thing over and over again at the minute. And this is the git to fuck another commit. Ugh. I need to get this here keyword. That's why I did it in the terminal. It's asked me to do this because it needs to let GitHub know who's doing the changes. I already have the SSH key, but it's like here, configure me so I know who's doing what. And I'm like, fine. Wait, is that username? Your name, I'm just gonna fucking. And then if we do git commit, and then git push, not hash, that's gonna put all those changes up. So then now we're on the behavioral style. Behavioral style is the highest level of abstraction. The main feature is this style. Of this style is that the functionality of a circuit is expressed in an algorithmic description. By using the behavioral style, a designer who does not know the details of low-level logic circuit design can design the circuits just as a programmer can develop software in C or Java. Although he or she does not know the assembly language at all. Okay. Yep. If S is 1, output Y as A1. If S is 0, then output Y as A0. I hate this. Look, that is the most fucking annoying feature ever. Can I turn this off? Fuck you, Microsoft Edge. Piece of shit. Nobody uses you. Can I open you in a different Firefox? Why did you open it in Firefox? Because fuck Microsoft Edge. Fucking Bill Gates, him and his Epstein shit. Wee beep beep. Dataflow behavioral style. So it's behavioral. It's doing a switch case. Switch case, but it uses the default. The default is 0, so only when it's 1 it'll output A1. Behavioral function case. I need to try and zoom in so that this doesn't look. Can you see now? Nope. Need to go over a bit more. Right. Out you go. Over you go. I appreciate this. Moving about is a bit fucking annoying. That should be it now. That should be as close as I can get to zooming shit in. I'm keeping everything on the one page. Okay. Thanks for the video and teaching, so I don't need to read the book. No problem. Yeah, don't care about this shit. Behavioral function, if else. I don't know, that's the same thing. Combinational circuit design. So, the outputs of combinational circuits are, right, I'm gonna, don't tell me this is frozen. I can't be dealing with this today. There we go. Combinational, right, I'm gonna split these into their relevant sections. So behavioral style will be, I didn't do any behavioral style. I did data flow style. Gate level was the 3S and the gate. Oh, fuck off. Level. Gate level. Bop bop. Don't know why I did that. 3S gate. And you go. Yep. Behavioral. No, data flow. Didn't do behavioral, I don't think so. Data flow, get to fuck. Where the fuck is behavioral? Transistor, I'll do a transistor one. Transistor. That one, that one, that one, that one. That's a transistor. Boo. And this one. Fuck off. What? What the fuck is wrong with this? There's only one data flow, okay. That's why that's doing that. Right, combinational time. Let's fucking go, boys and girls. Drink time. Combinational, so this is where we're getting into the big 32-bit yolks. Mux 2x32 dot v bosh. And that was my throat after drinking Coke Zero. Mux 2x32 A0 A1 S and Y. Then we want an input 310 A1 or A0 A1 input S. What is this doing? Oh, 10% battery left on the phone. Oh well. Output 31 to 0 Y, and then assign Y is equal to S question mark A1 or A0. So if S is 1, it'll output A1. If S is 0, it'll output A0. So we have two 32-bit inputs and one 32-bit output. So it's like a 2 to 1, but it's not 1 output, it's 32. So do end module. And then if we look at this, it should give us it, hopefully. It might shit a brick. Y is equal to S question mark. Oh, it really doesn't like this one. So it doesn't, oh, did it do it? Yeah, it did, okay. So yeah, that's your multiplexer, and then 32-bit A, 32-bit A1, and then S to switch between them. Cool. The following code implements the 32-bit 4-to-1 multiplexer. A 4-to-1 multiplexer selects one input from four inputs. It needs 2-bit selection signal. Yeah, so basically 0, 1, 2, 3. 0, 1, 2, 3, so that's your 4. I'm not gonna write the tests for these because I'm being lazy. What is it? 4 to 32. So if we change that, then we do A2, A3, and then we need S1 to 0. Nope. Fuck off. S1 to 0 output. Yeah, we still have only one output, and then we do. Why is this doing this? Function. I don't understand this, but I haven't done this kind of thing before. Maybe it's because it's the switch cases. Yeah, it is, okay. So let me see. Function. Select. Okay, so it uses the what? Call the function parameters. Okay. So we have input. Are you missing the argument in the first line? Indeed, good spot. A2, A3 per programming at its finest. Input. Just need these again, don't we? And then case S, and then two-digit binary. So where the fuck is it? That one? Is it that one, or is it that one? No, it's that one. B00. Fuck yeah. This is doing my head in. So 1, 2, 3. And then colon. Select is equal to A0. Fuck me. Select is equal to A1. What am I doing? A2, A3. And then end case statement. And then assign. I forgot. Can we only use case within function? I have no idea. I've never done this before. Again. Y is equal to select A0, A1, A2, A3, yes. I'm copying the book. That's all I'm doing. End function. Put that back. And that should do that. And we don't even have a fucking test case. Do we have an do we have a test case? We don't. which is a bit annoying. Right, fuck it, I'll write one for this one, just for the shits and giggles. Do, 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 do. Yeah, it shouldn't be too bad. That was me thinking, by the way, that wasn't me, like, having a stroke. Get rid of this. Right, let's do the test cases, boys. 4x32. That's right. So then mux 4 32 you test bench. Yeah, I don't know why he's done it like this. I wouldn't have thought you would need to do the function thing for a switch case, but we're here now. And here, right, okay, so yeah, fucker. And then we need, I need sunshine, I need, oh, need to give all these their widths. This is why I didn't want to write the test case. I just couldn't be arsed. 1, 2, 3, and then we need to give the wire its bits as well. Colon that shit, semicolon it, excuse me. So then what we can do is A0, A1, A2, and A3. So then what we can do is 32 hex and then just do FF. Is that right? FF is 8. FF and then LR FF. Fuck. Or what we can do is have it so that they move along, and then that way it's kind of visible and fun to see. And then, so if we start with 0, and then 1. So I'm setting all them, and then I'm gonna do to be. I'll cycle through each of these. So 1, 2, 3. And then I think in theory I'll just go y will equal this, and then this. I think. But I'm not entirely sure if that will happen or not. Transistor, nor these tests were a bit more sensible. We want time A3, A2. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. S. I need to do these other two then as well. A3, A2, and then were we done that before? I don't think so. We'll try and see. I don't know if this will work, to be quite honest. So let's just see. We're gonna hope for the best. Combinational. Chmod. Run. This is why I've been putting them in folders, because now I need to do this. 4x32. That one, and that one need to go in here. And then we can go in and then run it and pray that it works. Fuck, I'm not able to read that. No, okay. I'm just being stupid. I need to display this up here, and then take this and display it there. Fuck off. There. And there. And then it should be okay now. It should show us everything. So when S isn't set at this point, so it's X. So if I get rid of move that down, move that one down, move that one down, and move that one down, and then get rid of this one. So every time S changes, Y should equal that one, then that one, then that one, then that one. I appreciate this is a bit fucking awkward to look at, so bear with me. So we have S is 0, 1, 2, 3, A3, A2, A1, and A0, and then Y. So A3, A2, A1, A0, and then Y. So Y, as S is incrementing, Y is also gone up, so that does work correctly. Again, it's a bit of a fucking weird one, but I've just sort of messed up a bit. That's fine. Oh god. Well, the good news is my number of views has already reached and beat the NI Assembly question time for education. So that's worth a drink. And a Haribo. Unfortunately, that's not alcohol. Okay. This is just the most fucking awkward thing ever. So I have an easier way of explaining this, provided my understanding is okay. So these represent 0 to 7 in binary. So 0, 1, 2, 3, 4, 5, 6, 7. I can double check that with the calculator, but I'm 99.9999999 sure that that's right. So 1, keep an eye here. Oh, it's kind of hard to see. Can I zoom in on that? Nope. When do we use grey code? I don't know what you mean grey code. So 1, 2, 4. So 1, 2, 3, 4, 5, 6, 7. And then basically all of these can have an input on, but only one of these will have an input out. So if we think of these as the binary representation, it then selects the output based on the binary representation. That's basically how a decoder works. Only change a bit at a time. I don't know what you mean. If that's the thing in the book, I have no idea. Right, so we're gonna do a 3-bit decoder. Is this in part of the combinational bit? Yeah, it is. Okay. Decoder. Oh, I'm gonna rename it. Fuck. 3 to 8. 3x8. What am I doing? So 3 to 8 decoder with enable. Oh, there's an enable button. We're getting fancy. Decoder 3E. .v. So module decoder 3E and ENA D input. So we have a 3-bit input, which is N, our number in binary. We also have an enable button, not button, input. And then we have the output. So the output is basically, because everything's represented in binary, it's 2 to the power of however many bits we have in. So it's 2 to the power 3, which is 8 bits. 0 to 7. And 0 counts as a bit. So if we do 7 to 0, D, reg, 7 to 0, D. D cannot be a wire. So it needs to be an output. So I think because it's an output, it has to, the output goes into a register, whereas a wire, if it's going between two things. What is reg and wire? That's what I think the reg is a place where you store, like, a reg is a register, so it's basically where you store an output, and then the wire is for interconnecting within this module. I believe that's the way it's separated. Always at ENA or N begin and module. So D is equal to 8 B0. So can't use wire for output. I think so, yeah. If we go and look at all of these other ones, I don't think they use any. So there's a reg as an output, reg as an output, reg as an output, reg. Whereas all the wires are for interconnecting within. So wire here, the wire y is not assigned to wire. So wire only has SN, A0, SN, A1, S. Yeah. So our decoder D and oh fuck off. D N is equal to ENA. I need to process this a minute in my brain. So always at basically means anytime there's an input N or the enable button, then output. But if this is enable, I don't understand why we're writing enable in there. I don't understand why we're doing that. Let D equal to all zeros first, then let the nth bit of D equal to ENA. So I think basically what they're doing here is, let me see, can I? It'll probably take a hot minute. I don't know why it's so fucking slow, it's so annoying. But if ENA has a 1, then you pass in the number to N, and it then outputs that 1 at ENA to the nth bit. So for example, if the enable bit is 1 at any of these, then it'll output. So for example, if ENA is 1 and this is 7, then it's going to output a 1 to this 7th bit. I don't know what this not working is doing my head in. Yo, works. So does this say neg? Meg. What the fuck is this doing? Shift. Oh, that is the most awkward fucking thing ever. Don't like that one. So yeah, basically, and then if it's 0, it doesn't matter what's in here. Everything's just set to 0, which is what we do here. So this is setting everything to 0. And then if N is whatever, it doesn't really matter, because if this is set to 0, then anything that's in N is going to be 0. So that's our decoder, and then the encoder does the opposite. So if you basically have if you only have one line, and if you ping the 6th line, it'll then output 1 and 1, because if this is where the 0, 1, 2 is a bit awkward, because this is binary 1, this is binary 2, and this is binary 4. So if we put this high, it's equal to 6, and then 6 in binary is 2 and 4. If I go to this, there's 6. So we only have 3 outputs. And then if we put a 1 at 7 instead of 6, then we put 7. That's our encoder. And it's doing the same thing here. So 7 or 6, it'll go 1 1. And I don't know why what G is. What the fuck's G for? If we do not want to add G, we cannot distinguish whether the value. I'm so confused. An encoder performs the reverse operation of a decoder. It has a maximum of 2m inputs and m outputs. So if it has 3 inputs, if it has 3 outputs, then we go 2 to the power 3, which is 8, and we have 8 inputs. Oh god. The symbol in the truth table to an 8 to 3 encoder are shown in figure 212. 2 4 respectively, as shown in figure 212. Input, output. Another output G indicates whether there is a 1 in D7 to 0 or not. If we do not add G, we cannot distinguish whether the value of the input D7 is 0 or 1. What? That doesn't make any sense, but if it's 1, it should be 1 here. Oh, I don't like this. This makes no sense. Well, it does and doesn't because... Yeah, okay. So, because if this is meant to be decimal, if this is 0 and we put this to... If we put this to a 1, it is 0. So, these are going to be 0, but then you can't tell if it's 0, if this is 0. Sorry, you can't tell if this is 0 because of this or because of this. So, God, that's awkward. Okay, fine. The truth table for 2.5, that's fucking awkward as hell. We can draw the logic diagram or write the data flow style Verilog HDL code based on the logic expressions. And I'm gonna move this so we're actually when around talking. Oh, I farted. So is it gonna... Okay, it's doing the HDL or the GTK wave stuff. Right. I'm gonna go to the toilet and I don't know how long I'm gonna be, so I'm going to do the BRB. We're back, baby. Right, okay. So what's the next bit? Oh, right, this here. Encoder. I don't know why it's 8EP. So I don't. Right, let's do the encoder. Move this back over. Encoder 80p. And then module encoder 8EP D ENA and G. Now we need to input our 7 inputs in, input ENA, output 2 to 0, output the G, and then assign G is equal to ENA ampersand or D. I don't understand that. If there's at least 1 in D. What's this ENs? Did I do ink? No, maybe that's an inbuilt function. Ink. Oh no, is it? Oh no, it's this here. So ENA D, then function 2 to 0 ENA. Oh no, ENC. Input E, input D, 7 to 0. I think when I finish this one, I might do something else. Case X ED. God, this is awkward. I cannot be bothered typing all this shit out. Oh, I forgot I don't have that. I have to type it out. No! So 9 B1 underscore 1 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8. Okay, it's 8. Alright, fine. Ink is equal to 3D7. And then once I have that, I can just copy and paste the shit out of it. Bop, 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 bop. 01. Fucked it up already. Have I? No, we don't need that one. That one's the default. This is 0. And then the rest of these are 0, 0, 7, 6, 5, 4, 3, 2, 1. Yeah, it's okay. Default end case end function end module. Okay, so now we have that. I can do the test case for this. I'm going to. Where the fuck is it? Ah. Right, encoder. I need to copy and paste this. Yeah. And then I'm gonna copy and paste the inputs and the outputs. So in the test bench, it's a bit weird because we need registers for our inputs and then the wire for our output. Oh fuck, I know that's right. And then get rid of these. Oh, is N's an output, isn't it? Yeah. Via. And then what we can do is get rid of that. If ENA is 1, ENA is equal to 1. 1 binary. Then what we need, if ENA is equal to 1, and then D is equal to, if I do 8-bit, and then do 0, 1, XX, XX, 1, 2, 3, 4, 5, 6, 7, 8. Then in theory, my output should be 6. I better look just to see there's no test. No, there's not. That's fucking great. So yeah, if this is my input 1, 0, 1, 1, 0, 1, then my output should be 1, 1, 0, 1. I'm not even going to monitor it. I'm just going to run it and then open the dump vsheet. No, I'm not, because I need to install GTK Wave. And then I'm going to run this now. Did it finish? Yeah, it finished. Did it finish? Yeah, it did. So if I, yep, okay. Can I open this? Open with waveform viewer. Oh, okay, I can. Cool. Right, so this is our encoder, and then if I copy or if I insert all them. Oh, I don't like that. Why is that doing that? I think it's because I've done that instead of doing, you know what? I'm just gonna put 6 in decimal. And rerun it. Hmm. It doesn't like the fact that, well, I don't know what it doesn't like. It doesn't like this. But the output's coming out as 6. Oh, hold on. I don't think I saved it before I rerun it. Yeah, okay, that's better. So our input is 6, which is here, so I can change this to binary. Although it doesn't want to change the binary. Fucking annoying. Binary 0, 1, 1, 2, 3, 4, 5, 6. Okay, so I do that again. And then view it. Again, it should do the same job. Fuck. Nope. I did 40. Yeah, it works though, because if this is 1 and the rest are 0, then it's gonna go 1, 1, 0, 1, which is what we have. Now this isn't a third test, but it'll do for now. Oh, I know why it's 40, because it's in hexadecimal, so it's going it's going like this, I believe. It's going like that, so it's 1, 2, 4, 8. So that's why it's 40, because it's in hexadecimal. If we change it to decimal, it'll be. Why is it 64? Oh, aye, that's right, because I'm being inundated. Because that's a 64-bit in binary. If we change it to binary, but then if we also see, can I collapse that? Nope. A and A is 1, and then G is 1. So if I put A and A to 0, we'll get nothing out. Yay. 0 output, that's class. Okay, that's that one tested and done. Now, what else have we got left to do in this chapter? This is for the test. I don't want to do the full test because I can't be bothered. Demultiplexer, barrel shifter, sequential circuit design. We have a right bit to go. Basically another 20 or 30 pages. 25, 24. Yeah, okay. What gams have I got? Nah, fuck it. Let's just keep going. Let's just keep her lit like a bag of shit. Move things around. More. Boop. So we have a demultiplexer. A demultiplexer performs a reverse operation of a multiplexer. It has only 1 bit data input. How does it do that then? 1-bit data input and m-bit select signal. The output has 2 m-bits. So that's a multiplexer. 8 to 1 mux. Okay. A demux 1 to 8. Okay, so that's like, if that's 1, then you select it. Oh, but what's the difference between that and a decoder then? Or, yeah, a decoder. Because a decoder to me does more or less the same thing. Oh, I went past it. I have. So the decoder basically, that's how I don't get why do we need this? Okay, depending on the select signal, 1 bit of the output is selected to take the state of the data input. The demultiplexer performs the reverse operation of a multiplexer. It has only 1 data input, 1-bit data input, and an m-bit select signal. The output is 2 to the m bits, depending on the select signal. 1 bit of the output is selected to take the state of the. Okay. I suppose it's a bit more complex in what you can do with it. That would be why it would be used. Fair enough. Demultiplexer. Demux. 1 to 8. Okay, so output's only 1 bit value of y. The value of 2 to the power of sth bit equals y. So right, but I don't know why then we need to. I don't know what this is doing, to be quite honest. Specifically this. I can kind of understand it, so if S is 7, then it's going to shift this out 7, so it's going to put the 7 equal to this, the and of this, but yeah. Okay. And there's no tests. Cool beans. Y implicates to 8 bits. Okay. barrel shifter. A 32-bit barrel shifter shifts a 32-bit input to the left or right by 0 to 31 bits based on the on a right input and a 5-bit shift amount input. There's also an arithmetic input that indicates whether to perform a logical shift or to perform an arithmetic shift when right is a 1. A logical shift right inserts zeros in the empty bit positions, and arithmetic shift. Oh. Okay. I'm gonna stop this book stuff and go on to a wee game I'm messing about with. It's not a very interesting game. It's a ASCII C game I wanted to do. Do I want to do that? I could mess about with stuff on here. I do have some programming games. So I have Virtual Circuit Board, which is basically kind of what we were doing, but like in Paint. Upload Labs, not really Circuit. That is actual gates and puzzle solving. That is network engineering. Shenzhen IO could be interesting. Yeah, let's go through Shenzhen IO a wee bit. Oh god. Haribo. I love Haribo. Ba-da-mum. Diddly-doo. 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 Diddly-doo-doo-doo. I'm going to go. Okay. See you later. Bye-bye. Off full screen, do 1080p. Or will we do 19 by 1440? No, 1080. Or 19 by 1200, that might do. Can I zoom? I'll enable sound, I think. I'm gonna disable that because it's all coming through my mic. Rightio. Right, so this is the data sheet. Basically, this game comes with an actual data sheet, which is a bit nuts. And you get, there's data sheets for the different parts in the game. So if we go to the email, basically you start your job and you get loads of shit to do. And then click and hold this button to indicate that you've completed the objective. Design a complete and create No, I have not done that. Fuck me. I have not played this in a while, so it's going to take a bit of time. Buzzer thing. Prototyping new ideas, little help. Tag, you're it. Is there any reason these are awkward names? Excuse me. So, where is the... There's normally a wee thing in the bottom here. No, not that. Fuck off. No, I don't want to click and hold. Okay, so sometimes a decent product idea falls out when you're faffing about LCD panels. Okay, design and create an electronic game. Okay. So what can I do for an electronic game? Is this a screen? Balls. It is a screen. Shit. Oh dear lord. To add a custom screen to the sandbox. What was I doing before? Why? I'm wrapping up a project to create and design. I'm wrapping up a project to make a games console and could use some assistance. Nope. I have a friend. These are shite. It used to be good when they gave you like a thing to do. Right, fuck that. I don't want to play Shenzhen IO. I might just stop actually, because I'm tired and I'm pissed off from work today, so I'm probably going to end it and disappear, so